Good afternoon, my dear student. Today we will solve some problems related to network graph theory. So far, we have discussed about graph, tree, links, twigs, quadtree, types of graph, connected graph, unconnected graph, directed or oriented graph, undirected or unoriented graph, incident matrix, etc. Today we will solve problems related to this topic. Before going to solve numerical problems, let me tell you some basic concept regarding this topic. I mean graph theory. First one is reduce incident matrix. Everyone knows that incident matrix is nothing but a compact matrix which consists of nodes and branch of a graph, and it shows which branch is incident to which node. Okay, now you can say that reduced incident matrix is nothing but an incident matrix from which one row is deleted. Let me repeat this point. Reduce, the name implies that something is deleted or eliminated from the original matrix. Our case original matrix is an incident matrix which one is from from a directed graph. What is directed graph? Directed graph is a graph in which branches are assigned by arrows. Okay, so reduced matrix and incident matrix is said to be a reduced incident matrix when one row is deleted from it without losing any information in it. So let me write this definition of reduced incident matrix. Then we will proceed for solving problems. Okay. What is reduced incident matrix? You know incident matrix, directed graph, everything. Okay. What is reduce incidence matrix? Reduce means something is eliminated or removed from a matrix. For our case, we will reduce or remove. We will reduce or remove one row from incident matrix without any loss of information. You must remember it. An incident matrix. An incidence matrix is said to be reduce incident matrix, reduce incidence matrix when one row, not column, one row is deleted 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 from it without without losing any information. Okay, any information in it, without losing any information in it or associated with it. This is known as reduced incident matrix. Okay, so reduced incident matrix nothing but an incident matrix for which the order is actually decreased. The order of reduced incident matrix is lesser than that for original incident matrix. Now you tell me what will be the order of a reduced incident matrix if the order of original incident matrix is n by m. N by m. You know n is number of nodes and m is number of branch. Okay, now let me write it. For example, you consider the order of an incident matrix is capital N by capital M, where capital N is the number of nodes and capital M is the number of branches. Now you tell me what will be the order for a reduce incident matrix. Reduce incident matrix. Number of nodes actually. This one indicates number of nodes. Now you tell me what will be the order of a reduced incident matrix. Can anyone tell me? You know the order of an original incident matrix is capital N by capital N, where capital N is the number of nodes and capital M is the number of branches. Now you tell me what will be the order of a what will be the order for a reduced incident matrix. The definition tells us that one row is deleted from the original matrix in order to get reduced incident matrix. So if original matrix order is capital N, then for reduced case it will be capital N minus 1. One row is deleted. So therefore we can write from definition, or by definition we can write order of reduce incidence matrix is capital N minus 1 by capital by capital M, because one row is deleted and incident matrix is said to be reduced incident matrix when one row is deleted from it without losing any information in it. So you see number of nodes is n, one row number of row is n. So therefore order of reduced incident matrix will be capital N minus 1 by M. Okay, any confusion regarding the concept of incident matrix, formation of incident matrix from a given graph, or reduce incident matrix and their order? Everyone knows that order of a matrix means the size of the matrix, how many number of elements or how many number of entries are associated with a matrix. So you can calculate the total number of elements for a matrix by taking a multiplication between number of rows and number of columns. And for incident matrix, you know number of rows is equal to the number of nodes and number of column is equal to number of branches for a given graph. Okay, I hope everyone understand the concept of incident matrix, reduce incident matrix, formation of incident matrix, etc. Okay, now I will show you how do you draw a graph by using incident matrix. In last class, we have determined an incident matrix from a graph. Now we will see how do we can draw a graph from a given incident matrix. Okay, so let me give you a problem. Everyone consider everyone consider a everyone consider an incident matrix. Okay, let me write the elements, values of element of an incident matrix. Consider an incident matrix. Let us consider. Okay, consider an incident matrix. Incident matrix is consider an incident matrix. Capital A is given by, okay, uh, you just consider elements A equal to, let me write 1 0 0 1, then you write -1 -1 +1 +1 0, and third row is, elements of third row is 0 -1 -1 and -1. Okay, so this is a matrix. This is a matrix, reduce incident matrix. You write here A equal to, it's better. Okay, this is an incident matrix. Now you would draw the graph corresponding to this matrix. Draw the graph corresponding to this matrix, to this incident matrix. Okay, everyone knows that the steps involved to determine an incident matrix from a graph. You know it, in last class we have discussed. First step is calculate the number of rows that will be equal to number of nodes, and number of columns which will be equal to number of branches. After that we will calculate the values of elements. Okay, and to calculate the values of element we will first look out the uh, interaction, I mean, or incidence of a branch to any node. If a branch is incident at any node, then we will see the branch either enters to node or it leaves from the node. If it entered to the node, then we will consider -1. If branch leaves from a particular node, then we will take +1. And if there is no actually interconnection between branch and node, then we will choose 0. Okay, so here you see total number of nodes is 3 and total number of branches 4. It is given by inspection or by observation of the incident matrix. We can say that first everyone write the number of nodes and number of branches. After that we can draw a graph. A graph actually consists of number of nodes, some number of nodes and some number of branches, and these branches actually connect in the nodes. Branches connect nodes, and directed graph, there will be must an arrow associated with each branch. Okay, so for solving this problem, we will write first the number of nodes is How many number of nodes? You see this actually row corresponding to number of nodes. 1 2 3 3. Everyone try to understand the number of branches. How many number of branches? 1 2 3 4. Number of columns actually 4. You write here, that is number of rows, and here you write that is number of branches, columns. Okay, no doubt to understand this point. Total number of nodes and total number of branches for the graph corresponding to this incident matrix is 3 and 4. Now what you will do, you will draw the branches between nodes by knowing the values of branch current or element. So first you see this one is plus 1 element. You see element by observing observing the incident matrix. We can write incident matrix. We can write this node 1 is connected to branch 1, and node 1 is connected to branch 4. Okay, you can write here node 1, node 2, node 3, and branch 1, branch 2, branch 3, branch 4. Okay, so by observing the incident matrix, we can write node 1, this is node 1 is incident to node branch 1, and node 1 is incident to branch, sorry, you write branch 1, branch, actually branch will incident, branch 1 is incident to node 1, and also branch 4 is incident to it, because you see plus 1 plus 1. Okay, and plus 1 mean it leaves from the node, Okay, now let me draw the figure. Okay, let me draw the figure. Okay, and then I similarly you can write the relation between other nodes and other branches, branch 1, branch 2, and you see for node 1, branch 2 and branch 3 are not incident to node 1, that's why 0 0. So let me draw the graph. Okay, and okay, one branch, there are total 4 branches, 1, then 2. Everyone try to understand this point, and if you have any doubt regarding this part, you write in your chat box. Okay, and the final one is okay, you write another graph is better. There are 2. There are total 2 branches. It will be little bit one, another one you can write. This is not okay. Let me write like this. Later on you will correct yourself. Another node. Okay, there are total 4 branches and total 3 nodes. Okay, and you number it. You know it. Number node 1, node 2, node 2, and node 3. Okay, and you write branch. This is node 1, node 1, node 2, and node 3. And obviously you mention the name of the branches. Branch 1, branch 2, branch 2, branch 2, branch 3, this one branch 3, branch 3, branch 3, and branch, this one branch 4, branch 4. Okay, everyone see, and you just show the arrow, no, no, show the arrow. Okay, everyone look at the present slide where I have solved the given problem. How do you draw the graph from an incident matrix? The first step is to calculate the number of nodes and branch by observing the incident matrix. Everyone knows that number of nodes is same as number of rows of incident matrix. On the other hand, number of branch is same as a number of columns of incident matrix. After that, we will see the direction of branches, okay, by knowing the values of element. If +1, that means the branch is incident to that particular node and leaves from it. If -1, that means it incident to that particular branch, incident to the particular node and enters to it. And 0 means there is no interaction between branch and node. Okay, that means branch is not incident to the node. So you see, everyone see, I have drawn total 4 branches, 1 2 3 4, because it is given total 4 branches, 3 nodes, 1 2 3, total 3 nodes, and according to the value of element I have mentioned the arrow. +1, that means no, branch 1 is incident to node 1. This is branch 1 incident to node 1. It is connected to node 1 and it leaves from node 1. You see the arrow actually is opposite. Arrow is indicated to opposite of 1. That means +1. 0, that means node 1 is not connected with branch 2. Branch 2, you see, node 1 is not connected to branch 2. 0, branch 3 that is not connected with node 1, that's why 0. You see, this is branch 3. And branch 4 1 means it is connected to node 1. You see 4 is connected to node 1 and plus 1 means it leaves from node 1. That's why we have put arrow in opposite direction of 1. Similarly, you can find out the direction of arrow for node 2 uh, for node 2 with respect to different branch orientation. Okay, -1, that means node 2 and branch 1 is connected. You see node 2 and branch 1 is connected. -1, it entered to node 2, the branch 1 enters to node 2. You see arrow is given towards node 2. Okay, now you tell me you have any doubt to understand this to solve this problem. The steps to understand the steps involved to solve this problem, involve the solution part of this problem. Simple. You have already know, you have already calculated, determined the incident matrix from a graph. The vice versa, you just draw a graph from incident matrix. Okay, I hope everyone understand this, the solution part of this problem. If you have any confusion or difficulty to understand the solution part of this problem, you just write in your chat box. Okay, now I will give you another problem. I will give you in the similar manner. You can draw these branches. You can draw. Okay. Another problem is that I told you that in a previous class we can calculate the number of trees for a graph by knowing it, by knowing the value of its reduced incident matrix. Okay. Let me write this point here. This is a crucial point for graph theory. Number of trees. How do you calculate number of trees, okay, in a graph? In a graph, how do you calculate number of trees? Okay, you know number of a tree is nothing but a subgraph of an original graph which consists all nodes of the original graph and it has no closed loop or closed path. Okay, so to calculate number of trees for a graph, we will use a formula. Okay, the number of possible tree, the number of, and I will solve a problem regarding this formula. I will solve a problem by using this formula. The number of trees, possible trees, you write the number of possible trees, okay, in a graph, in a graph is given by you just use this incident. Capital T is the number of trees. Capital T equal to determinant of determinant of determinant of and transpose a transpose. This indicate transpose. Okay, where a capital A is the reduced incident matrix, is the reduced incidence matrix, and A transpose and A transpose is the transpose matrix of A, is the transpose matrix of A. Okay, transpose matrix of A. You can calculate the number of possible trees. Thank you Nivedita, you can calculate the number of possible trees for a graph by knowing its incident matrix. If you know the incident matrix, then you take determinant of the product of incident matrix and it transpose, and you can calculate the value, the total number of trees. Okay, so let me solve a problem related to this. Calculate the number of possible trees. Okay, I am giving you a problem. You just solve it yourself. Everyone, solve it yourself. You consider an incident matrix. Okay, problem. You consider an incident matrix. Okay, incident matrix. Suppose incidents and incident matrix. Incidence matrix is given by okay. What is the value? Is given by -1, 0, +1, +1, -1 and 0, 0. Then second row elements are 1, -1, -1, 0, 0, 0, -1. Then you consider 0, 1, -1, -1, +1, 0. Okay, this is an incident matrix. A equal to these things. Okay, this one incident matrix. Now you calculate the number of possible, calculate the number of possible trace for this incident matrix. Possible trace. So how do you calculate the number of possible trees? How do you calculate the number of possible trees? I have given an incident matrix. Now I am asking you calculate the number of possible trees for this incident matrix. And before that, I told you that to calculate incident trees, number of trees for incident matrix, you use the formula number of trees equal to determinant of the product of incident matrix and its transpose. So for this case, incident matrix is provided. Now we will calculate. First step is to find out the product value, the value of product of A and its transpose. Then we will take determinant. So what is the first step? First step is calculate the value of the product. Calculate the step 1. Step 1. Calculate the value or product matrix. Calculate the product matrix. You know that multiplication of two matrix will produce a new matrix. Okay, not a single value. So it's you write calculate the product matrix of capital incident matrix and its transpose transpose matrix. Okay, what is the next step? Next step is to calculate, to find out the value of determinant determinant of the product matrix. Value of determinant for the product matrix. For the product matrix. Okay, no problem. Now first we will calculate the product matrix. The A is given. A transpose you can take by rearrange the location of columns and rows. Okay, everyone knows it. So A is given. So A transpose equal to you can write, just you rearrange the number or replace rows by its column. Okay, so therefore for this case you will get total 4 number of rows and 3 number of column. So let me write it. Uh, you will transpose it. First you transpose it yourself. Okay, the transpose you will get how many? You transpose the matrix. You transpose the matrix. Three. Transpose the matrix and then you take oh, reduce incident matrix. One thing, you will just reduce one row first. Calculate the product of matrix of reduce incident. Don't write incident matrix. Reduce incident matrix and it transpose matrix. You see the definition here. Reduce incident matrix. So reduce incident matrix and it transpose matrix. Then final. The reduce incident matrix you just write reduce incident matrix AR equal to you just delete one row. So for this case you will get, let me write, reduce incident matrix equal to uh, reduce incident matrix. First reduce incidence matrix AR is given by you just if you delete one row from the original incident matrix, then we will get reduced incident minus, you just write -1 0 +1 +1. I think this one -1 -1 0 +1 +1 -1 0 -1 0 1 +1 +1 -1 then 0, and second row will be +1 -1 then 0 0 then 0 and finally -1. Okay, let me check it. My 1 -1 0 0 0 -1. Okay, for from this graph incident matrix, from this incident matrix we have deleted this part. Okay, you delete it. You delete this part. Sorry, you delete this part. Okay, this red color part you delete it. You write here deleted. This row is deleted. This row is deleted in order to get the reduced incident matrix. You see, this is the reduced incident matrix. And now you write AR 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 equal to this. Within third bracket, you write, no problem. This is the reduced incident matrix. Now you take it transpose. You make it subscript form, and now you calculate it transpose AR it transpose T equal to, you can write this row must be present it as a column. So we can write minus 1 minus 1 column will be row minus 1 you write minus 1 plus 1 minus 1 plus 1 then you write minus 1 plus 1 0 minus 1 then you write actually you write this row as a column. So first you write 1 0 1 1 0 1 then you write let me complete it first 1 then minus 1 then 0. Similarly, you write this row as a column matrix. You can write a minus 1 0 then you can write 0 then you can write 0 and finally you can write minus 1. You just make it similar from symmetric way, otherwise it looks like different, not a matrix form. Okay, and this one 0 0. Okay, this one okay. So this is the transpose reduce matrix. Everyone try to understand this one. Transpose reduce matrix 1 2 3 4 5 6 1 2 3 4 5 6. Okay, good. Now we will calculate the product matrix. Okay, first we have an incident matrix. From that incident matrix we have determine reduce incident matrix by deleting one row from it. Later on, we have determined it transpose matrix by rearranging the rows and columns or interchanging. You just write interchanging rows and columns. Okay. Now your objective is to calculate the product matrix. So you just take multiplication of these two terms. Multiplication of these two terms. Okay. New slide. Let me actually our main goal is to calculate the number of possible trees for this matrix. Okay, then we will what we will do, we will calculate the product matrix, then we will take determinant. The product matrix of a reduce and a transpose reduce is given by is given by you just make it as a subscript and it is as a superscript. Good. Given by the suppose p equal to what, equal to, you just take multiplication of these two things, ultimately you will get, I am writing the final value 4 minus 1 then minus 1 3. Okay, you just check it yourself. The product matrix will be 2 by 2 order. 2 by order, the order of the product matrix is 2 by 2. Okay, and the values of its element is 4 minus 1 3. You just multiply yourself and verify the values of element of the product matrix whatever I have written in this slide. Okay, everyone calculate the values of element of the product matrix, just simple multiplication, and then you check the values whatever I have written here. Okay, you compare with your actually uh, values, your obtained values. Okay, we have got the product matrix. Now we will we will calculate the determinant value. Determinant of product matrix we can write uh, by this symbol P mod P equal to, we can write, this is simple thing. You just take 4 common and you just this thing, this thing 3 12, and then you take this common, this cancel out, minus 1, 12 minus 1, minus 1 plus 1, so 12 minus 1 you will get 11, ultimate you will get 11. Okay, and let me write here 4, then you take multiplication, this then that means 3, then you write minus, is minus 1, minus 1 you just cross this row and this column, so minus 1 minus 1 plus 1 minus 1, so therefore you will get 12 minus 1, it will be 11. Okay, the total number of possible trees is 11 for this incident matrix. Total number of possible trees is equal to 11 for this incident matrix. Now you tell me your confusion or you have any difficulty to understand this solution part of this problem. Everyone try to understand the solution part of this problem because this is crucial. Sometimes this such type of problem comes in competitive exam, so you need to clear your concept, otherwise it is difficult to solve this problem. It is simple approach. We will calculate the product of a reduced incident matrix and a transpose, and after that we will take determinant of the product matrix. Whatever the value of the determinant, that is equal to the number of trees for a number of possible trees for an incident matrix. Okay. Okay, if you have any query, any regarding the solution part of this part of incident matrix, reduced incident matrix, the determinant, product, etc., you can write in your chat box. Then let me give you the final problem. This one, this final problem. You consider a graph has n nodes and b branch. Okay, then you calculate total number of independent current and total number of independent voltage equation. Actually, total number of independent current equation and total number independent of voltage equation, that means node equation and loop equation. Okay, let me write the last problem. Okay, I will give you some sample question for this topic. Okay, as assignment problem is that for a graph, for a graph, for a graph, number of node, you just write a graph has, a graph has n or a number of nodes and b number of branches, b number of branches. Okay, now you calculate calculate, okay, total number of independent current currents and independent voltage voltage, okay, equation. Current, independent current and independent voltage equations. Okay, do it yourself. You have already completed KCL, KVL, and that time you realize that number of voltage equation is equal to number of node, and number of current equation mean number of loop equation and number of mesh equation. And graph theory, from graph theory, you can also calculate the voltage and current for a circuit. And the beauty of the graph theory is that without rigorous calculation, by a simple graphical representation, we can solve a complex circuit problem. By a simple graphical representation, we can solve a complex network or circuit theory problem without rigorous calculation. Understand? This is the main advantage of the network graph theory. Okay. So you see, I am asking here how many number of current equation and how many number of voltage equation you will get from that graph, which has n number of nodes and b number of branches. You know that the number of voltage equation is equal to number of twigs, a number of branches associated with the tree. That means n minus 1. And you also know it from Kirchhoff voltage law, node equation. The total number of node equation and voltage equation is number of nodes and 1. Same thing you can write here from graph theory or any alternatively from uh, circuit theory concept. Okay, KVL, KCL. So you can write the number of node equation or number of voltage equation is capital N minus 1. Capital N minus 1. Okay, any problem? Everyone try to understand such type of problem will come in your NSEM exam or other competitive exam. You just try to understand, and if you have any doubt, you inform me. Okay, the number of independent voltage or tape, the number of independent voltage voltage equations equal to number of nodes minus 1. On the other hand, number of loop equation means what? Branch equation, loop equation or mesh equation. The number of independent current equation just you write in short form, equation equal to number of links which is associated with a co-tree or who is not as involved associated with a tree. Okay, the number of links equal to how many? Branch minus node plus 1. Branch minus node plus 1. Okay, any doubt to understand the theory, to understand the solution part of this problem? Last problem I am asking, the solution part of last problem. If a graph is given and asks you what will be the number of voltage equation or node equation and what will be the number of loop equation or current equation independent, then you can write number of voltage equation equal to the difference between number of nodes and 1, and number of independent current equation is nothing but the number of links. Same thing. Okay, number of links, the number of links equal to number of branch minus number of node plus 1. Okay, and I already told you in previous class what is the relationship between number of links and number of twigs. Number of twigs, twig is the branch of a tree and link is the branch of a co-tree or a branch which is not associated with a tree. So that is b minus n plus 1. So n minus 1 is twig, the links equal to branch minus twigs. This relation I already told you in last class. So, okay, uh, I hope everyone understand. Okay, if you have any query, any confusion or any difficulty regarding the concept of graph theory, whatever I have discussed, you can ask me, okay, now or later on. Thank you everyone, and let me stop today's lecture here. If you have any doubt, any query, you can ask me or you can write in your chat box. I will provide you sample question at least 72 or in some exam, and I will also send you an assignment of the topic whatever we have covered after Laplace transform. One assignment I will send you, and you submit it after your before your INSEM exam or after, okay, as your convenient, okay. And I will send you sample question for INSEM exam. Okay, thank you everyone. If you have any doubt, any query, you can write in your chat box. And tomorrow, I mean on Friday, I will take the lab experiment number 8 for group A student, okay. So tomorrow we will complete the experiment number 8, who is actually we do not complete it, we do not complete before that.